Okay guys, so we did not do so hot on our Unit 4 test. So I'm going to try something a little bit different this week. I'm going to go over the test with you. This week I'm going to record some lessons for you to watch. And hopefully that will help you understand what we're doing a little bit better. You're going to hear probably Hallie in the background, so just ignore that. We're going to start by reviewing. So before you watch this video, you need to make sure you have your test paper and a red pen. So you know we don't write in pencil when we're correcting. So make sure you have those things. Pause it if you need to. And then I'm going to go through it with you. As I go through, you know everything that I write, you need to write. And we're going to practice this because on Friday you're going to take a quiz. And that quiz is going to replace whatever grade you got on this test because most of us did not pass it. Okay, so let's start with question number 1. How many centimeters are in 50 meters? So when I look at a centimeters to meters question, I need to think back to the paper I glued in my journal that looks like this, that has the different titles on it: kilo, hecto, deca, unit, deci, centi, and milli. Obviously this is centimeters and meters, so this is what I'm going to use. So on my test paper I need to remember King Henry died. Oh, no, that's what I learned in high school. Sorry. King Henry doesn't usually drink chocolate milk. So we're starting with meters. Meters is not this little m. Meters is our base unit. It's our base unit. It means it doesn't have a little prefix in front of that. Mr. Lazarus would be proud. I used a vocabulary word. These are called prefixes. This does not have one in front of it, so it's our base unit. So we are starting right here. Then it says we're moving to centi, so we're going to end up right here. Now think back to powers of 10. These are powers of 10, so all I have to do is see how many times I moved. I went 1, 2 to end up here. So I'm starting with the number 50. Well, I don't see a decimal there, but I know that's a whole number, and the whole number always has a decimal on the back of it. I'm going to move that decimal 1 time, the same direction. Uh-oh, what happened? I need to put a placeholder 0. I move it again. Uh-oh, same thing. I need a placeholder. Now it matches, so I'm going to rewrite the number. That says 5,000. So the answer is C, 5,000 centimeters. The other thing to remember is if I'm going from a bigger unit like this, I'm going to need more of these to make that. So you should have written this and moved that decimal like powers of 10. If you need to pause to make sure you have everything I have, pause it now. And then I'm going to move on to question number 2. Okay, question number 2. Now this one, it's actually going to be easier. Are you talking to them? It's actually going to be easier on Rise because these things that describe these shapes, if I don't remember them off the top of my head, on Rise, you can search in the dictionary for these words and it will literally tell you the answers to each one of these boxes. If I just search rectangle in the dictionary on Rise, it will tell me that a rectangle does or does not have right angles. It has parallel sides. It will tell me all of that information and then I can use it for this question. For these, you're going to have to remember what's in your journal that looks like this. Yours is in black and white and it looks like this. It's called the hierarchy of quadrilaterals. So as I go down, I'm adding more attributes, which are these little like descriptions, to each one of these shapes. So let's look at this question. Select the boxes to identify the attributes, which remember just means like descriptions. Attributes of all rectangles and all rhombuses. Okay, think about a rectangle. I'm pretty familiar with a rectangle. A rhombus, I might be like, I don't totally remember, but a rectangle I know a lot about. I know a rectangle has to have 4 right angles. I've known that since 3rd grade. Does a rectangle have to have all equal sides? No, that would be called a square. Does it have two sets of parallel sides? Well, yeah, these two are parallel because they will never touch going this way. Remember parallel, think pair of L's. They will never touch each other. Then we go up and down. This one will never touch this one. So that's one set, two sets. So yes, it has two sets of parallel sides. Now a rhombus is kind of like a square that's been squished a little bit. So all my sides are the same, but I don't have right angles. That's the biggest thing. So, must have 4 right angles? No, we just looked at it and it's squished. A rhombus does not have to have right angles. Must have all equal sides? Yes, it must have all equal sides. And 2 sets of parallel sides. Well, think about it kind of like a square that's been squished. Even then, this set right here is never going to touch. They're not going to touch each other. And these ones are never going to touch each other. See? Parallel sides be following Kaifuti. Y'all need to follow Kaifuti also. Okay, that's what you need for this question. So make sure that you have everything I have. Pause it if you need to. And then we'll move on. Yeah, you tell them, write everything down. Callie says write everything down. Okay, this one is a RISE question, and it is trying to trick you. So you have to think about this more than just like, oh, well, that's easy. I see the answer. The line plot shows different measuring cups a baker used to measure flour. What is the total amount of flour in cups the baker used with 5/8 measuring cups? So if I look at this, each one of these X's tells me a time that the baker took a scoop, scooped it, and dumped it, right? If I look at the 5/8, they did that 2 times. But my answer is not 2 because it said, what is the total amount of flour? Well, if I scooped 5/8 twice, that's not 2 cups. That would be if I used a 1 cup. If I take a 1 cup measuring cup and I scoop it 2 times, then I have 2 cups. But I used 2 of these 5/8. So I said 5/8 plus 5/8. Well, I know how to do that because those already have the same denominator for me. 5 plus 5 is 10. 8 plus 8, don't let me trick you, we don't add the denominator. So I have 10 over 8. Now, I was very nice with this on the test. I took any kind of answer you gave me. So if you said 10 over 8, even though that's improper, I counted that as correct. But because it's improper, we have to simplify it. And we know when something is improper, we divide. So 10 divided by 8. 8 goes into it 1 time. Oops, 8. With 2 left over. Remember, our remainder turns into a fraction. So I also took this one, 1 and 2/8. But if you notice, this is not finished because those are both even. So if you did the final step of factoring, 1 and 8, 2 and 4. Their greatest common factor is 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. That gives me 1/4. So I also took 1 and 1/4. Any of these answers are correct. If you put 2, that would be very nice, but you know RISE is not going to make it that easy for you. Pay attention to 2 of what? You scooped 2 5/8, not 2 1 cups. I'm going to give you a second to make sure you have all of that. If you're confused, go back and watch it again. Pause it, rewind it, and go watch it again. Okay. Moving on. Question number 4. Again, we're looking at rhombuses and rectangles. So it's almost like this is probably what you're going to see on RISE. Select the boxes to classify, and classify is a fancy way of just saying name. Just means give it a name. Classify each shape as a rhombus or a rectangle or both. So if I am looking at this, before I even really think about the rules of this, I can look at this shape and decide that's very obviously not a rectangle because it doesn't have right angles. So that has to be a rhombus. And I just talked about how a rhombus does not have right angles. So it does not have to have right angles. So I'm not going to assume it's these two. But I can look at this and see that this is a rectangle. This one is a square. So if you look at the flow of the hierarchy, everything that I go down matches. So this rhombus is also going to be a square. A square can be a rhombus. So if I go back, this gets to be both because it meets all of the rules. It gets the rules of the rhombus and the rules of the square. So a rhombus can have right angles, but it does not have to have right angles. Okay, next question. This one was super easy and most of you got this one wrong. You have this in your journal, but you don't even need this because usually on Rise they're going to give you these kinds of questions where it says the conversion for you. You don't even need to go and figure out what the conversion would be because it tells you right here. Again, if it doesn't tell you for some reason, you can put it in the dictionary and the dictionary will tell you what it is. So, if I am Enrique and I'm having a fruit punch using 12 cups of pineapple juice, I want to triple the recipe for a family party. How many quarts of pineapple juice do I need? They're trying to trick you right here because they said triple. They put that in word form. What does triple mean? Times 3. So before I even do my conversion, I need to make sure I have the total amount of cups. So 12 times 3, Enrique's going to need 36 cups of pineapple juice. And then once I have that, I can figure out if I'm going to multiply or divide to figure out how many quarts that would be. Now, this is something I didn't get to teach you. Let me see if I can show myself in Hallie. Hold on. Oh, we're upside down. I think the best I can do is sideways, guys. Hold on. Okay. I hope you can see me. I don't think you can see me very well, but I hope you can see me enough. So when we go from a bigger unit to a smaller unit, this is how I remember it. I'm going big to small. My arm made an X, so I'm going to multiply. When I go from small to big, I make a division sign. So let me put you back on the paper for a second. Oh, let's say hi to Hallie. Oh, wrong way. Say hi. Okay. Flip you back. Okay, so I am going from a smaller unit, because cups are small. If I think about a cup of ice cream or a quart of ice cream, I would rather have a quart of ice cream. That's more ice cream. So I'm going from a smaller unit to a bigger unit. So think about my arms. If these are my arms here, I'm going from a smaller unit to a bigger unit. I make a division sign. So I'm going to divide 36 divided by 4. 36 divided by 4. Now, if I don't know that multiplication fact off the top of my head, I'm going to need to go ahead and do the actual division. But 36 divided by 4 is 9. So that is 9 quarts. Now, hopefully, if you got this question wrong, what you did instead was 12 divided by 4 equals 3, because at least you understood that you were dividing. If you did none of those things, then that's why you got to remember my arm trick, because that will help you. If I'm going from not a number that's bigger or smaller, but the label. So if I'm going from a small label to a big label, I'm going to divide. I'm going to show you one more time. I'm going to be upside down. You're just going to have to get over it. Okay, here we go. I'm going from small to big. I'm going to divide. I'm going from big to small. I'm going to multiply. Hopefully that will help you a little bit. Okay. Let's move on to question number 6. Okay, I will tell you this question is definitely hard because it's actually an addition or subtraction question with fractions. They just make you have to do a little bit extra work. I was very nice to you and I told you that each one of these marks is actually the same thing as saying an eighth. So I showed you that this is, well, let's think about this for a second. If this is a half, half of 8 is 4, so this is 4 eighths. 5 and 4 eighths, 5 and 5 eighths, 5 and 6 eighths, 5 and 7 eighths, 6, then we're going to do 6 and 1 eighth, 6 and 2 eighths, 6 and 3 eighths. Now that's important because once we read this question, we're going to have to do something. What is the difference between the tallest and the shortest heights? So I look at here, this is where the first X is. So that tells me that this is the shortest. And here's the last X, so that tells me that this is the tallest. Now it didn't give us a number here, and that's why we have to do this. It would be a lot easier to say, oh, well, that's 6.5, but it's not, because each one of these marks is an eighth. So now that I know it's 6 and 3 eighths, because remember the bigger number has to go first as a subtraction, minus, because difference means subtract, 5 and 4 eighths. Well, I can start by doing the whole numbers, but look at my denominators for a second. I cannot take 4 from 3. I have to regroup. We cross off the whole. This turns into 5. We add the bottom to the top. That means this is actually 5 and 11 eighths minus 5 and 4 eighths. Well, 5 minus 5 is just 0. 11 minus 4 is 7. And 8 minus 8, we don't subtract that, so it's just 8. I could write 0 and 7 eighths, but that would count it wrong, so just write 7 eighths feet. So that is the difference between the tallest and the shortest. So again, hardest part about this is that you're going to have to figure out what this number is, and then you have to remember we cannot take 4 from 3. You have to pay attention to that. It would be a lot easier if I could, but I cannot give somebody 4 cookies if I only have 3 cookies. Alright, next one. Again, this is one of those shape questions that these triangles, if you don't remember what these triangles are, all you have to do, listen to me carefully, all you have to do is take the name of the triangle and type it into the dictionary, and the dictionary on Rise will tell you what you need to know about these. The good news is for this question, you don't even actually really have to know much about it. You just have to understand how the Venn diagram works. So as I go in, everything before it still applies. But if I go out, it doesn't. So the equilateral rules do not apply to the isosceles. Think about if the triangle is Mr. Roberts. Mr. Roberts gets to decide all of the things for everybody. But if we go in, this one is Miss Heinig. She gets to decide the stuff for our Monticello, and this would be the other Monticello. Their decisions don't decide for you. Mr. Roberts gets to decide, but the principal over here doesn't tell Miss Heinig what to do. Miss Heinig tells the teachers what to do. Does that make sense? So the teachers don't tell Mr. Roberts what to do or tell Miss Heinig what to do. They tell this what to do. So if I come here, let's look at the rule. All I have to do is see which direction it's moving. So it says all equilateral triangles have 3 sides of equal length. Okay, it just told me a rule. It didn't tell me any information yet. So all isosceles triangles have 3 sides of equal length. So that would be saying, because this rule is here, this one has to follow that also. So the teachers are telling Miss Heinig. That's not how that works. So we're going to say that this one is false. The teachers don't get to tell Miss Heinig. The inside doesn't get to tell the outside what to do. Every equilateral triangle is an isosceles triangle. That goes this way. Well, that works. So that's true. A scalene triangle can also be an isosceles triangle. These two aren't even touching. So because they're not even touching, they don't have anything to do with each other. We're going to say that's false. Every isosceles triangle has at least two sides of equal length. So every equilateral triangle has at least two sides of equal length. So again, if we look at, we're following the rules. We're going from here to here. That works. Last question. Which category on the Venn diagram is the least specific? So that means which one has the least amount of rules that they have to follow. Well, if you look at it, what's the biggest circle? Who has the most control over everybody? Triangles. It's just the triangles. Think about it as Mr. Roberts. It's the least specific. Okay. Question number 8. The list below shows some attributes of a shape. So remember, attributes just mean descriptions. The first one, at least one right angle. Second, at least two pairs of parallel sides. And the last one, at least two sides of equal length. Which shape always, this is important, always have the attributes in the list. So not just sometimes, but always have those things. We're going to choose all correct answers, so there's more than one. Okay, starting with one right angle. I know a square has a right angle. A right triangle, well, that sounds like it's going to have a right angle. Rectangles have right angles. But an isosceles triangle, there's nothing in there that tells me it does. And it's a triangle. And triangles don't always have to have right angles. If I didn't know, use that dictionary on your RISE test. You can search that word and it will tell you more information. And then same thing with parallelograms. I don't really know that off the top of my head. If I had my journal, I could look at my journal and see there's nothing that says this has to have a right angle. But if I don't and I'm taking the RISE test, I can use the dictionary to look this up. But they do not have to have right angles. So already I've gotten rid of two of them. And it says at least two pairs of parallel sides. Well, I know a square has this pair and this pair. So that one still works. Well, a triangle doesn't have pairs of parallel sides. So that can't work. And then same thing with a rectangle has this set and this set that are parallel. They're never going to touch. They keep kaifuti. So that one also works. And then the last thing says at least two sides of equal length. Well, if I look at this, two sides of equal length. A square, all the sides are the same, so that's at least two. They have four, but that means they have enough, so that still works, and that has to be correct. A rectangle has these sides that match and these sides that match, so that's at least two also. So A and C are the correct answers there. Okay, a maintenance worker is replacing worn rope on 6 flagpoles. Already, pay attention to that 6, that's going to be important. The worker uses 40 feet of rope, for each flagpole. So for one, we use 40, but there are 6 of them. I want to know the total, but I want the total in yards. So I'm going from feet to yards. Well, there are, feet is a smaller label than yards. Feet is a smaller label than yards. So let's start by figuring out what my total is. I have, each one is 40 and there are 6 of them. So I can add 40 a bunch of times, or I can say 40 times 6. Well, what's 4 times 6? That's 24, and then bring that 0 over, 240. So right now I have 240 feet. Now I have to decide if I am going to multiply or divide. So again, you're going to see upside down me. Here we go. Okay. I'm going from small to big. So I am going to divide. It's not about number, it's about label. So I'm going from a smaller label to a bigger label. So I need to divide. I can look at this and say what's 24 divided by 3, but if that's hard for me, I can do the actual division here and say, well, 3 goes into 24 8 times. and that means that I have 80, which means my final answer is 80 yards. It really all comes down to, am I going from a smaller label to a bigger? And what I mean by that, guys, is if I put a foot in front of you and a yard in front of you, what's bigger? Well, 1 foot, I wish I had something in front of me. Let me think. Oh, I have measuring cups. Hold on one moment. Okay. Let's see here. I got measuring cups. Oh, that actually doesn't work. Let me think. Do I have a tape measure? Okay, think about a tape measure for a second. Imagine I have a tape measure. Here's my tape measure. This whole thing is a foot. This little bit is an inch. So even though there's a bunch of inches on here, the bigger label is a foot because 1 foot is bigger. The inches are little tiny pieces. So when we're thinking about a yard, think about a yardstick. They're those like really long things that teachers use sometimes. And they have 3 feet inside of them. So this is 1 foot here, but this whole thing is a yard. That whole thing right there. So I'm going from this smaller piece to this bigger thing. And that's why I have to divide. Okay, I hope that helped and didn't confuse you, but that's all I have in front of me right now. So that's all I can do for you. Okay, one last question on this test for you to look over. Which shapes have always, so again we're looking at always, have the properties listed below? Write the letter of each property in the correct column of the table. Properties may apply to more than one shape. So what I want you to do is take one piece at a time and check it for these things. Again, if I'm taking rise and I don't remember, I'm going to go to the dictionary and I'm going to type the name of the shape in the dictionary and it will tell me the attributes of that shape. So 4 sides of equal length. Well, if I think about a rectangle, 2 of the sides are the same and the other 2 sides are the same, but not all 4 sides are the same. Squares have all 4 sides the same, and if a square has it, that means a rhombus has it also. Okay. B, 2 pairs of parallel sides. Well, rectangles have these and these and these and these, so yeah. Squares have them, and a rhombus has them, because they're all what we call a parallelogram. A parallelogram means we have 2 pairs of parallel sides. Remember, think of like Mr. Roberts. Parallelogram is telling all of these things. They have to follow that rule. Then I have 4 angles. Well, they're all what we call quadrilaterals. So quadrilaterals all have 4 sides and 4 angles. So we can give that one to everybody. Then we have 4 right angles. Well, I know that a rectangle has right angles and a square has right angles. These ones have right angles, but this one does not have to have right angles. And the last one, 2 pairs of perpendicular sides. So for this one, perpendicular means that they're going to intersect at right angles. We know that, let's draw these shapes that will help us. A square, and we have a rhombus is kind of like a diamond, but a little bit different. Oh, that's a very ugly rhombus, but I think you get the point. So if we're talking about perpendicular, yeah, you tell them. We're talking about them all coming to these right angle points. This is going to make that. This is going to make that. This one, don't stress too much about it, but the correct answer is going to be that rectangles have that and squares have that. Okay. Let me see here. Okay, so like I said, you're going to take a quiz. Before you take that quiz, Miss Potts should be passing out your test review in case you didn't get it last week. Miss Betzer told me that you might not have gotten it. So if you did not get that, Miss Potts will be passing out. If you already got it, then don't worry about it. If you want to go back and work on it again, you can. You can use those pages in your journal. But like I said, if you didn't, Miss Potts will be passing it out. And then every day you have a do now that I will go over with you. And that do now will be kind of similar to what your quiz will look like on Friday. So when you come in on Friday, your do now will be the quiz. The rest of the things we're going to do this week is we're going to review what we know about fractions. So tomorrow we're going to talk about adding and subtracting fractions. So finding those common denominators, making sure that they have equivalent fractions. Then when we get to the end, we have to make sure we simplify them. So we're going to review that and look at some questions that are from RISE with that. And I'm going to work through that with you. So don't stress too much, but then you are going to practice it at the end. And then on Wednesday, you'll do a little bit of RISE practice with that. Thursday and Friday, you're going to do multiplying and dividing. So we're going to review fractions this week. Okay, I hope that this helps, and I hope that this makes this a little bit easier for your unit test. I hope you paid attention and you're still working hard in class. And I miss you all. I'll talk to you more this week. Bye.